This is the last lecture for support reactions. Actually, in this lecture, I have taken a special sum, okay, in which you can do or you can find support reaction with the help of two methods. First one is our regular method, means equilibrium methods, means step 1, 2, 3, 4, 5, etc. In which you are taking sigma h equal to 0, you are taking moment at the left support, you are taking sigma v equal to 0, and then after you are finding the resultant reaction. Okay, this is the conventional method. But the same support reactions can be found out with the help of Lami's theorem also. Okay, you must know about Lami's theorem. Lami's theorem we have studied in the chapter coplanar concurrent forces. So with the help of that method also, we will discuss the support reactions in this numerical. Check out the question first. For the overhanging beam shown in figure, okay, in this figure the beam is overhanging. You can see the beam is overhanging after the point B, right side. Compute the magnitude and direction of the support reactions at A and B. Okay, so you have to find support reactions at A and B using two methods. First one is equilibrium method, means our conventional method, and second one is Lami's theorem. Okay, now see the beam carefully. Actually the beam is very simple, in which only one and one only load is acting at point C. The load is actually inclined in the downward direction. You can see over here, inclined in the downward direction at point C. Now slope of the inclined force 170 kilonewton is given as 15 and 8. The angle theta is made with the horizontal line, means 8. So you can calculate tan theta is equal to 15 by 8. So theta will be available now 61.92 degree. Okay, so theta is equal to 61.92 degree. So theta is available. So hence you can make a component, vertical component and horizontal component of this 170 kilonewton. So 170 sin theta is the vertical component. By replacing theta over here, you can find in the calculator it is 150 kilonewton. Okay, vertical component. A horizontal component is 170 cos theta. Replace this 61.92 again in the same equation. You will find 170 cos theta is equal to 80 kilonewton. So these are the vertical and horizontal components. Now what is our method? When horizontal force comes into the picture, we have to replace horizontal reaction also. Where is the horizontal reaction? Horizontal reaction must be at the simple support, not on the roller support. So you can see over here in this figure, point B is the roller support while point A is the simple support. Okay, so I have replaced at point A horizontal reaction HA. Where is HA? What is the direction of HA? So HA is in the direction exactly opposite to the applied force. So here you can see at point C, the horizontal force applied is towards left side. So reaction should be in the opposite direction, right side HA. Now you are wondering that why this VA is going down. Actually VA is going down in this figure. It means that when we calculate support reactions, maybe the value of VA will be negative. So when VA becomes negative, it can be drawn downwards, but it doesn't matter. You can start with the upward direction also, but you will get the answer in negative value. Okay, what is length of the beam? Length of the beam between A and B is 2.5 meter, you can see, and length of the beam between B and C is 0.3 meter, you can see in the figure. And at point B, support reaction is VB. At point A, support reaction is VA. Okay, so these are the pure figure based sum. Only one inclined force is present at point C. Now let us see how the equilibrium method help us. It is already useful to you as you have studied it earlier. Now, so the same figure is replaced over here. Let us start with sigma h equal to 0 first. Now what is sigma h equal to 0? It means right forces equal to left forces. So here you can see right force is HA and left force is 80 kilonewton. So HA is equal to 80 kilonewton. So this is the calculation for horizontal forces. Okay. Now let us start reactions using condition of equilibrium, theta is already now available 61.92 by means of 10. Now taking moment at A, taking moment at this point. Okay, so how many forces are there? First force is this 170 sine theta, means 150 kilonewton. Now what is the distance from point C to point A? It will be 2.8 in total. So answer will be 150 into 2.8. It is going down like this, going down. So it is clockwise. Now another force is this VB. VB is going up. Okay, so upper force will give anti-clockwise movement like this. So anti-clockwise movement, distance from VB to point A is 2.5 meters. So VB into 2.5. So answer will be VB is equal to 168 kilonewton. So VB is equal to 168 with the help of calculator. Now what is our conventional method? VA and VB, two forces are there. So if we have to find another reaction VA, then we have to subtract VB, means final reaction, from total vertical load. Now what is total vertical load? It is 150 kilonewton, you can see over here. So subtract 150 minus 168, as we have find out VB is equal to 168. So answer will be in negative value, VA will be minus 18 kilonewton. So hence VA is going down. So now we are finding resultant reaction RA, which is equal to under root of VA square plus under root of HA square. So VA is equal to minus 18 now, and HA is equal to 80 kilonewton. So by replacing the values, you can get the answer of RA is equal to 82 kilonewton. And angle of resultant reaction is equal to tan alpha. That is mode of VA upon HA. By replacing the values of VA and HA, you will get alpha is equal to 12.68 degree. So here alpha is equal to 12.68 degree. So how many reactions we have found out? You don't concentrate on HA and VA separate components. You just concentrate on RA. Okay. So why? Because in Lami's theorem, we only calculate RA directly. We are not going to calculate HA and VA separately. We just calculate RA. Then after we will calculate VB, and we will take the help of this 150 kilonewton. So while going to Lami's theorem, only three forces are available. First one is RA, means resultant reaction somewhere over here, and second force is 170 kilonewton inclined, and last force is VB going vertically up. So let us check the figure now. Okay, so this is the figure of Lami's theorem. Now we are calculating the same numerical with the help of Lami's theorem. Check out, we will find these three forces. Please check in the figure. First one is VA, second one is 170. Actually 170 is from coming down from upward direction like this. Concentrate on the figure. It is like this, coming from this direction and made a tensile force like this, 170. Now here it is the angle 61.92 as we have calculated with the help of tan alpha. This distance is 0.3 and this distance is 2.5 meter. Distance is not mattering right now. Now just angles are mattering. Here it is force HA, here it is force VA, and resultant is going in this direction. Resultant of HA and VA is going in this direction. You can see this is RA. Okay, and this angle is tan alpha, means alpha 12.68 we have calculated earlier. And this is the vertical reaction VB at point B. So you just concentrate that at this point. You can see at this point all the forces are concentrated or concurrent, because it is the condition of Lami's theorem that three forces must be concurrent at some particular point. So at this point you can see 170 is going down like this, RA is going down like this, and VB is going in the upward direction like this. Okay, so now let us check the game of angles. This is 61.92 degree. So if you draw dotted horizontal line over here, you can see dotted horizontal line, then this angle will also become 61.92. This is also 61.92 2. So this angle is vertically opposite to it, this. So this is also now 61.92 degree. Now what we want, this is 12.68 degree over here. So this horizontal line, you can say this horizontal line and this dotted horizontal line are parallel. So this angle will also be 12.68 degree because it is corresponding angle. And then after this angle is also 12.68 because of vertically opposite angle of this. Okay, so this all angles are 12.68 degree. So only two angles are mattering, 12.68 degree and 61.92 degree. So with the help of these angles we have to calculate Lami's theorem right now. So let us check how the Lami's theorem is going. You can see using Lami's theorem we have to find RA first. So while we are taking RA, in the division sine of angle between other two forces is required. So we are taking RA, okay, from this. You can see, concentrate on the figure RA. So what is the angle between other two forces? It is from VB, you can see it is from VB to 170, this one, this total angle. So you can see VB is vertical only. So first one, this angle is 90 degree. Okay, this is 90 and in this 90 you will add 61.92. So you will get the total angle 90 plus 61.92. Okay, so first step is complete for RA. Now second step is for VB. So while you are taking VB, this force, vertical force VB, then the opposite angle from RA to 170 is required. So this angle will be 180 is the total horizontal line angle. From that you just subtract this 61.92 and this 12.68. Okay, like this. So you will get the required angle. Now the third value is 170. 170. So for 170 means for this force you have to take this two angles, 90 plus 12.68. So 90 plus 12.68 is the angle between other two forces. By doing calculation you will get the simplified values in the calculator. RA upon 0.47 is equal to VB upon 0.964 is equal to 170 upon 0.975. So by simplification you will get RA equal to 81.95 kilonewton and VB equal to 168 kilonewton. Now these two angles must be equal to these two reactions must be equal to earlier RA and earlier VB, which we have calculated by the help of equilibrium method. So you will check this RA is 81.95. So what is in equilibrium method? So you can see here RA is 82. Check out this 82. And what is VB? 168. Check out here VB 168 and RA equal to 82. So here RA is equal to around 82. 81.95 means near about 82. And VB is exactly equal to 168 kilonewton. So this is the main logic, or this is the main magic. With the help of Lami's theorem we can also find the support reactions. So this is the very simplified, or you can say very master magical sum, in which we have used two methods, equilibrium method and Lami's theorem also. So goodbye students. In the next lecture we will definitely start a new chapter. Its name is moment of inertia. So you just revise center of gravity first for this new chapter, moment of inertia. So we will start the chapter with very ease. Thank you very much students.